In this video, we are going to solve the problem which is related to the derivatives of composite functions, and it is the following problem. So given the capital F as defined and conditions that second derivative of small f is minus small f of x, and small f prime is equal to g, then we have to show that the capital F is a constant function. If you want to try to solve this problem, you can pause the video and we'll give now the stepwise solution. So as I started, now we have to show that f is constant. Now what do derivatives and constant functions have in common? Well, there is many things, but there is one theorem in particular. We have that if f prime of x is 0, then f is constant function. And this is what we want to use here. Function. Okay, so our goal is now to find f capital prime, so the derivative of capital F, that is plus g of x over 2 squared, then derivative. So we want to find the derivative of each function. Now, before we do that, let us just analyze here. So analyze f of x over 2 and then square. So this is a composite function where if you take as u of x equals f of x over 2, and then you take v of x to be x half, then basically you have u of v of x and then squared. So how to find the derivative of that? So let us just put v of x equals t for the moment, so that we have u of t squared and then prime. So that will be u 2 times u of t times u prime. And then, knowing that u is u of v of x, then this implies that u prime is u prime times v prime. Okay, so this is according to the rule of the derivative of composite function. In our case, therefore, we will have f of x over 2 and then square, and then derivative of that is 2 f of x over 2 times f prime x over 2 times x over 2 prime derivative. You can again pause the video and take a look carefully at this. And now we can write this is 2f of x over 2 times f prime x over 2 times 1/2. So that the derivative of this is f of x over 2 times f prime x over 2. Now let us just forget for the moment about x over 2 And we can just write formally that that is f times f prime. As a matter of practice, you can perform all the steps for g of x over 2 and then squared, and you will see that the derivative of this is exactly the same. There is no difference, so we can write g times g prime. Therefore, we can write f prime is f times f prime plus g times g prime. So let us call this 1. Now we have additional, and we want to show that this is 0. Okay, if we show that this is 0, again, we don't know anything about f, capital F, but something else we know. We will now use these two conditions, additional, that might help us. So f, so second derivative of x is minus f of x, and f prime of x is g of x. So f prime of x is g of x. Let us call this 2, and this we are going to call 3. Now, from 3 implies that g prime of x equals f prime, or second derivative, and that is minus f according to 1. So here implies by differentiate. So differentiate. So if we differentiate 3, both sides, we have that. And now using 1, we have that g prime of g prime equals minus f. So we can say, so from 1, sorry, here is 2. Here is 2, not 1. So let us write f prime of x is f times f prime plus g times g prime. Now, this we can rewrite plus g is according to 3 f prime times g prime. But this is again according to 2 g prime, and this we are going to call now 4. So according to 4, f times f prime plus f prime times, you can see here g prime is minus f. That means f times f prime minus f prime f, and that is thoroughly 0. So we have shown that f prime of x is 0, therefore f is constant. And that is what we are supposed to do. first we have obtained this relation, then we have called our two given relations 2 and 3 to obtain relation 4. You can see we have 3 and 2, and then we are able to use that to conclude that f prime of x is 0. Thanks for watching.